Angular, anything other than React. Okay, and React people, React folks, no one. Us. Okay. Um, okay, that's going to be okay. Interesting. So, how many people have worked with functional languages? That could be JVM based, non-JVM based, any languages which support currying and thank you. Um, Currying and awesome. Okay, so let's get started. So what is React.js? React.js is a library to abstract DOM and its interactions. The way we write in React is component based. So React makes our code modular. It forces you to write in a MVVM style against MVC style. What I mean by that is your controllers end up being as part of your view components itself, and your view models they end up as state or props to your components. Moving on, why React? So React has virtual DOM and synthetic events. So what is virtual DOM? Virtual DOM is a representation, in-memory representation of your DOM, which allows you to perform patching, diffing on top of your DOM. It allows you to make, yeah, hello. It allows you to make changes cleanly. As in, like, if you have a bunch of updates, virtual DOM handles updating DOM, or it rather does it in place. So, for example, if you are changing a huge set of divs, you'd either be adding, removing, or maybe changing one or two values. So, instead of changing the entire div or re-rendering the entire div, it basically does those in place updates. I'm sorry, I don't have that example, but let's take a simple chart app. Cool. Okay. So this is a very simple chart app for the purpose of this talk. On the right, you can see the user list. On the left, you can see the message pane. On the bottom, you can see the message box. So Gaurav is me, of course. Simple is another user whom I'm messaging to, and this is a very simple app. So what I'm trying to say here is it's all component based. So what you see here is basically one component being rendered inside which multiple small components being rendered. This makes the code modular. So let me just show you the data model. So this is the view component hierarchy, what we have. So you have the layout, the user list component, the message pane, which is for a particular user. Then you have the message as itself being rendered, and the user component, which is part of the right-hand list, and the photo component. So let's dig deeper into one component and see how the code is, right? So you have the photo component here. So what you're seeing is a pure UI component. That is, it does not maintain any state of its own. The UI component basically renders itself as and when its props, or re-renders itself as and when its props changes. As you can see, you have just the render function. Of course, the code here is in ES6, and you have the JSX templating library being used. JSX templating, which is used for div. Yes, this is not HTML. This is HTML within your. It looks like HTML within your JavaScript. It's not. It's basically JSX being rendered, which gets compiled down to JSX using Babel. So what it does here is it computes basically what the image should be for the photo component and renders the div with a proper class name and the proper image. Now, how do you optimize this render? So the thing with React is it pre-renders. So the way we work with React is when we have changes, we re-render the entire app. So how do you optimize render, or how do you avoid components which need not unnecessarily be updated or re-rendered. So even though virtual DOM avoids repainting the DOM, it does create the virtual DOM tree. As in, like, it creates have what components have to be rendered, and it then checks what needs to be changed between them. Now, to avoid generating the virtual DOM tree and to avoid having those methods, so those components being rendered, you can use the should component update function. So let's extend our previous example. So should component update has a very simple API. It basically says, hey, if I return true, do update this content. If I return false, hey, don't. So looking at the photo component, I have my should component update method being defined on the photo component. So it has this dot should component equals to should component update dot binds. We look into the internals of the common should component should update file, which is implementation we have borrowed from Omniscient. The reason I'm telling you about this is it helps us in short circuiting, or rather not even computing what needs to be def by the virtual DOM algorithm itself. So if you look at should component update, it has a very simple API. It takes in next props and the next state. So when you compare the current components, props and state, like, we have implementation where it checks against this the current components state and props to check if any new props have come in, and it basically returns if it is not equal, then re-render at the end, as you can see. So where is the brain? Of course, my talk was React apps with a brain. So immutable data structures and cursors. So what do I mean by immutable data structures? So people who have worked with functional languages, they would know what immutable data structure is. But just to give a brief, immutable data structures are update resistance against threads. So even if you have multiple threads, and if you update immutable data structure, you're bound to have the same structure, as in, like, the concurrency will be maintained across thread. In the case of immutable data structures, and cursors allow us to actually have proper to actually navigate through immutable data structure. So we have an immutable data tree. Let's look at what we have for the messaging app. So if you look at state, sorry, before that, I'll just show you the app sheet. So this is the app sheet. Of course, we are using Immutable and Instruct. Immutable is a library, again, open source by Facebook. Instruct is by Omniscient, the guys from the React version of Clojure, the Clojure version of React. And we are initializing app state with the instruct of state of an empty map. And we are trying to build a state tree. So the state tree in our messaging app looks something like this. We have the state, we have users, current user, and route. The users have multiple users, user ID. Under a particular user, we'll have messages, and we'll have multiple messages with a message ID each. So when we are rendering methods, what we do instead of, so yeah, as you can see, this is the app.js, which shows that if a app state, so whenever the app state tree gets updated or being touched, we basically re-render the entire app. This allows us to not think of updates, not think of DOM manipulation as such, but to think of an app as pure FRP, as a pure functionally reactive program as such. So when the state itself changes, you can think of something like Excel, where you have, when one cell updates, you have multiple cells updating which depend on that cell. So you can think of it in that sense. So maintaining our own abstraction. So given that we have the state tree, it gets complicated to actually access the data inside the state tree. So what we have done is to write our own component abstraction, which allows us to access the state tree. As if you look at users, state users, this is basically getting all the users in the app for painting that right column, the user list as such. Now, what we do inside the component method as such is to render the child component as a children to a anonymous component actually. So as you can see, the component function returns a new React component which renders the child component by computing the props. So this dot get props function based on that tree, based on that path which we specify, gives us another React, gives us props to that new child component which we have defined. So just going back, user list component is being redefined. If you can see, we have the users list component defined here, which gets redefined based on the return of the component. So it gets rewritten as such. Before I move on, so isn't mutating state ugly? Yes, it is. It is very ugly in the sense you have to keep up with the different states. So in case of backbone models, you have to keep up with what has happened with the model and then listen for the changes in the view, in the backbone view. So to avoid all this, what we have done instead is to use the immutable structure, which allows us to not really mutate state as such, but to provide functions which allow us to update the state in the tree itself, in the immutable structure itself. So how do we leverage this at Tarka Labs? So I'll give you an example demo app which we have built for a client. Not sure. I think the internet's slow here. Yeah, it's not rendering properly. But otherwise, if you look here, we have a we have list of drivers, and we have a map showing where the drivers' positions are as such. So, well, wow. I wasn't expecting having a case of driving driver. But as you can see, what's happening here is when the driver is driving, we actually follow the driver and render the app and show the moving driver's actual position. Because of using a state tree and mapping it one to one with a view component hierarchy, it makes it very easy to reason about the state as well as to reason about what app changes need to happen. So this is one case of such things. Um, Questions? Of course, the sample code is available at Sample Express Chata. You can look through that. And any questions? Way too fast. Any comments? Suggestions?
So, React provides virtual DOM data.
Yeah.
Basically, the DOM structure is in memory,
Right.
and whenever you make a change to the state, it
Right.
updates the DOM.
It updates, it re-renders the virtual DOM,
Virtual DOM,
and the virtual DOM does that defect to update the DOM itself. Yeah.
So, this is done at a global level, or can it be done at a component level as well?
So what happens really is in our case, we re-render the entire app. Of course, we can pick out the parts which we don't even have to, because we have that should component update function, which basically says, hey, this component has not changed at all because its props or its state haven't been touched. And due to that, we can actually restrict only to the components whose state, whose props have changed. Because of using immutable, so you think that comparing or diffing objects itself would be difficult. But with immutable JS, what it gives us is references. It gives us cursors, which allow us to see, which allows us to directly compare those cursors and see, hey, this has changed, and that's how we do it actually.
But I was asking more towards whether it is possible to do it at a component level, or is it you must do it only at an app
As of now, no. There is no such API to actually render only that particular, like attach directly the state to a particular component. No.
So you change the state of the entire app.
Yes.
Rely on
There's just one global state, like as I said before. So you have just one global state, one global app state. So if you see, we are exporting one global app state, which maintains the entire state hierarchy. And if this tree changes, if this state changes, we are re-render the whole app. So if you look at the code, it's something like, hey, if app state has any change, any swap on it, re-render. That is run the render method again. That's the global render method.
So the advantage would be that you don't actually touch the browser's DOM. It's terribly slow.
Yes, we don't touch the browser's DOM. We don't we don't write it in an imperative fashion. In fact, so if you look at a pure UI component, it would have just you can basically strip it out and you can have just the declarative form of, hey, this div needs to be rendered with this props, and that's it.
For example, if I have, for example, take jQuery. So jQuery, you have a grid, and in the grid you need to reach the 10th column, 10th row, that cell.
Mm-hmm.
Right. So what you will do in jQuery is probably you will loop through the entire each DOM node.
I'm sorry, grid.
Each DOM node. You will
Right.
be looping through each DOM node
Right.
to reach that particular cell.
Yeah.
So in React, this does not happen.
React, you don't. Okay, so I'm assuming you'd be looking for that particular DOM element to update it or to manipulate something on it. So React, you would not do that. Even when you're attaching events, even when you're listening on any particular DOM element, you'll be attaching synthetic events on it. So you have something like similar to on change. You have on key press, on key up, and on key down. You have all such methods available in React itself. Of course, they are cross-browser compatible, so you don't really require something like jQuery to do your events. So now, just to give an example, when what happens in a message box. So this is a message box rendered method. Message box is of course this guy here. So when you're actually sending, when you're hitting enter, what happens here is you have a on key down, or you have a on click event over here, on click, which actually sends the message. Any other questions?
What is Newstruct? What is that?
So Imstruct is a immutable. It's a library which provides you immutable data structures within JavaScript itself. So the two predominant data structures which you use are, of course, list and maps, which are hashes, and arrays in other languages. Now, since we have immutable data structure, it makes it fairly simple to do diffing on the data on the state itself. Like as you can see in the should component update. Also, immutable data structure, the immutable data structures thin wrapper which we have, mstruct, allows us to listen on events on state changes, on the data hierarchy changes.
Immutable.js also provides
Yes.
so both immutable.js and instruct.
Instruct is a wrapper. Instruct is a wrapper which makes it easier to access immutable cursors. So immutable itself has cursors and cursor implementation. If you look at immutable, this is immutable. This itself has cursors. So cursors are paths to our particular JavaScript like data path. So if you have a nested immutable data structure, you can actually say, hey, this is what I need, or this is what I'm looking at. So, for example, if I show you the message pane, which is the so if I show you, so if you're looking at this, I'm saying, hey, this is the path which I'm interested in. So I call something like appstate.cursor for this path. Give me the cursor. So cursor is something like a pointer. It's not exactly like a pointer because you don't have actual memory backing it. It's basically something which is um, which is an abstraction over the actual data itself. You still have to do a .dref to get to the data. So it provides you with the tree, with the way to access the tree itself. Any other questions?
Is there a way to split, separate out those HTML tags out of this JS in case of everything?
As of now, no. So you have to deal with JSX. So that's the recommended way. So what you're seeing here as HTML is not really HTML. What it compiles down to is JSX. If I can show you an example for that, it would be awesome. Uh, yes. So if you look at this like JSX editor, if you see, you have the render diff, and when it gets compiled down, when it's compiled to JavaScript, it's actually just a JavaScript call to react.create element. So JSX is just basically a syntactic sugar on Dart. It makes it very amenable to writing HTML code. You can think of writing HTML code, but thing is not everything is the same. So for example, you have class which is not present in um, JSX. So you can't really have class because that's again a keyword in JavaScript.
My point is, let's say that I'm a developer and we are UI developers. Okay.
Right.
I don't want the UI developer to actually go and fiddle with this stuff.
Right.
Getting the divs to span or spans to some other stuff.
Right.
Or adding extra classes.
I completely agree. So thing with React was even I had that same concern. Even I had that same thing against it. Okay, hey, I'm writing HTML like code right inside my JavaScript. But the thing is, if you think of React, they are just components. They are actually view components. If you can compare, if you have to compare with something, you can think of something like cells in Rails, where you have view partials. Like it's not exactly partial; it's a holistic end-to-end part of the page actually. So React components are just part of the pages. So if you're thinking in that terms, hey, you're just writing HTML. You are supposed to write HTML inside your React.
So I can still write instead of JSX react.dom.div, and
React.create element, what you're talking about is. You can write React.create element, div, null, hello if you actually want to deal with this API.
Very verbose.
It is very verbose. It is very so. This is just a very simple example. When you start having child components to that component, it becomes very hellish to deal with it. Thing is, React has plugins for multiple other libraries, so you don't necessarily have to think of writing HTML. It is a library which you can write you can 3.js, which is a 3D library. You have multiple other charting and multiple other output which is similar to what you do using virtual DOM. So it's just an abstraction on rendering any kind of code, not just DOM, but any kind of code. So the performance, so the thing with this is we have been seeing 60 FPS. So what you're seeing over here, so actually this app has a 60 FPS. That is all the updates, the driver driving does not actually cause a performance problem as such. It's true even for mobile browsers. So thing is React has all those cross-browser compatibility. So you can use it as such without any facing much of a performance problem. Of course, the alternate way of working with React would be to use Flux, something like the Flux architecture where you have actions, dispatchers, stores, and then you have the component itself. Thing is that does get messy. So you have functions or closure being thrown around. You have events listening. So thing is, when you're listening directly to events, when you're listening directly to actions, there can be memory leaks, which can happen. With our code, we haven't seen any memory leaks. Of course, you can test out the app which is there, the code which is there. This is embarrassing. I'm not sure why that happened. That's the first time I'm seeing that unresponsive. Um, so the so the sample app, you can actually test it out for yourself. Though it's very simple, like you can just play around with the concept as such. Cool. I guess we are done.